This time we're going to graph a quadratic that's in intercept form. When you see the parentheses and you don't see any exponents, this is in intercept form. So we're going to start by graphing the x-intercepts. So in this case, again, it's always the opposite of what you want to say. So the x-intercepts are -7 and 5. It's the opposite of what you want to say. Think of what would it take to make that equal 0. So we're going to start by plotting -7 and +5. So these are our x-intercepts. This is our one set of points. So we're going to work backwards now to get the vertex. And if you remember, one of the ways to do this is you could just do it quite literally by counting. So we could count 1, 2, 3, 4, 5 spots, 1, 2, 3, 4, 5, and find the halfway, which would be exactly at x equals -1. But if you don't want to do it by counting, you just take the average. What is the average of -7 and 5? Well, we're going to add them together. So -7 plus 5 all over 2. We're going to get -2 over 2, and we are going to come up with an axis of symmetry that is at -1. If we know the axis of symmetry is there, then we can definitely find the vertex. So all we're going to do is plug in what happens when x is -1. So when x is -1, we're going to get -1/4 times -1 plus 7 is 6. -1 minus 5 is -6. So you're really going to get that y is equal to, let's switch our stylus, y is equal to -36 all over -4. It's going to become positive, and it's going to equal 9. So your vertex is -1, 9. And you have graphed all the points that they asked you to graph. Now, normally, you are asked to graph a second set. So let's say, how would you find a second set of points? Well, I'm going to pick something that's in between my vertex and my x-intercepts. I'm going to go and try out what would happen when x is 1. And I'm choosing 1 this time because if I choose an odd number, when I plug it in, it's going to make these parentheses even, and it's going to make it much nicer to divide by 4. So over here, we're going to write y equals -1/4 times, and we're going to plug in +1. 1 plus 7 is 8. 1 minus 5 is -4. I'm going to do negative times negative is a positive. And you can either cancel or you could say 32 over 4. I'm going to cancel. So I'm going to cancel this 4 on the bottom with this 4 on the top. And I'm going to be left with y is 8. So when x is 2, y is 8. So I'm going to go out to 2, and I'm going to go up to 8. Plug those points in. I'm 1, 2, 3 spots away. Go 1, 2, 3 spots away on the other side. And definitely connect this so it looks like a curve. It's very wide, and that's because we're growing at 1/4 of our normal speed. Now, before you even graphed all that, you could have answered a whole bunch of questions. And so let's take a look at some of these questions. Does it open up or down? Well, you have a is equal to -1/4. It's negative, so it definitely opens down. If you have a parabola that opens down, it is going to have a very topmost point, so it's going to have a maximum. In this case, you knew the roots to begin with. There were 2 roots, and they were the x-intercepts. They were the point -7, 0 and the point 5, 0. So the only thing left to do now is to find the domain and range. So let's check it out. Because there are arrows, our domain is still going to be all real numbers. You're not going to find a leftmost or rightmost point. And that's why it's all real numbers. So what we really have to look at is what is the range, because this definitely has a starting point. If we look at 9, this graph exists everywhere from 9 and below. So the range is y is less than or equal to 9. But if you like interval notation, let's just carry it down here and write it. What is the lowest point possible? There isn't. We're at negative infinity. So we can't contain that, so we're going to write negative infinity. What's our highest value? It's positive 9, and we can equal that. And there you are. So just remember, when you're in this form, they gave you the x-intercepts. Start with them, work backwards to get your vertex.